All right, everyone, welcome to the second edition of the Wilkes Student Lightning Talks that we're going to be doing right now. So we have an hour allotted for this event, and a lot happens in that hour. We have 10 different students who will be doing 3-minute talks, lightning talks. And so I'll be moderating, and let me just give a rundown quick on how the whole session is going to unfold here quick. There's 10 presenters. I believe we have 9 undergraduates, 1 graduate student. The time limit is 3 minutes, so it's a hard limit on time. And then we leave 2 minutes of time after each presentation for 1 question from a judge. And then we move on to the next presenter. We work through all of those 10 presenters. And there'll be voting that takes place at the end of the session. And there are actually 2 separate votes that will be occurring. There's an audience vote that happens at the very end that's going to happen using a QR code that I'll post, and then it'll link you to a Google form. And then the judges have a separate vote they're doing via Google form. And so yeah, for that one at the end, anyone can vote in the room. It's a popular vote, so feel free to participate in that aspect of this. Okay? And so with that, welcome everyone, and we're going to get the first presentation underway. So Aspen Marshall. Down is forward.
Hi everyone, my name is Aspen Marshall, and I was an undergrad student in atmospheric sciences where I recently graduated last semester. And so I did a project on something that happens very like County, Salt Lake City. And so here in Salt Lake City, our ozone concentrations are above the EPA's national ambient air quality standard of 70 parts per billion. And so for example, even just yesterday, we exceeded that limit, which is bad for human health as ozone could enter the fluid line of our lungs and causing COPD, asthma, and other respiratory and cardiovascular conditions. And especially, like, ozone formation is governed by NOx VOCs, where NOx is NO plus NO2. VOCs are organic compounds, such as from both biogenic and anthropogenic sources. And also, marginalized communities are experiencing high levels of pollutants and increased rates of mortality due to pollutants. And so these are 2 results. These are 2 figures I chose. And so the first one on this left is VOC fixed in gas stations. So gas stations are sources of VOCs for compounds. And so these concentrations are decreasing when we go from gas station, except for this increase here for the benzene and toluene. And that was because it's refinery. When I looked at all petroleum storage tanks, there's a decrease across everything. And then on the right, we have these concentration curves. So this is like population weighted burden by Moran percentiles. This is from the Environmental Protection Agency's EJ screen platform, which was taken down last year. But the blue line represents equality, where everyone experiences some of those pollutants. And then if orange line is below that line, marginalized communities are exposed to more of those pollutants. And the orange line is above that line, there's the non-marginalized communities are exposed to more pollutants. And so for NO, NO2, and some of the VOCs, marginalized communities experience high levels of those. And for ozone, generally equal for everyone, but non-marginalized communities are exposed to slightly increased ozone. And my guess is that is because NO could deplete ozone, and so pressure emissions, so NO could be depleting those ozone, but chemical modeling might be done to verify that. And so it shows that marginalized communities are exposed to high levels of NO, NO2, and VOCs, and that's bad because those are going to increase rates of mortality. Then ozone is going to decrease, but chemical modeling should be done to verify all that information, and that's usually appear to be a source of VOCs, and that's it.
Yes. Going to use the mic.
Yeah, so that we can connect to that we're recording. Thank you.
Do the VOCs come directly from the gas station pumps mostly, or is it from cars? So would you see could you look at more busy gas stations versus less busy?
I mean, that's how this can be done. My guess is that the gas station pumps are a direct source of that, because the current ones we have here in Utah, these 0.7 tons of carbon per 1,000 gallons, while newer gas station handles that are better for stopping fumes, these only 0.05 tons of carbon per 1,000 gallons, so they're a lot cleaner. And so it seems like gas stations are a primary source of VOCs. But then the chemical modeling might be done to actually verify the information. And it'd be cool to do like actual field campaigns, so specifically around these gas stations, but that was not the focus of this research.
Thanks, Aspen. Okay. All right, we'll move on to the second presentation, Baylee Olds.
Okay, did you go into the canyons this winter and expect to see something like this? And instead, you saw something like this. This past winter has been the worst snowpack year for Utah on record. Climate change is decreasing snowpacks across the West. Our water managers rely on statistical relationships to forecast stream flow that climate change is rapidly disrupting. In addition to this, climate change is also increasing the extent of drought and beetle kill, with increasing in wildfires due to forest overgrowth. So what is the solution? Well, the long-term solution is to decrease our carbon emissions. Our short-term solution, I'm here to convince you that we can minimize wildfire risk while maximizing net snow water input by strategically managing our forests. To do this, we need to understand what drives snow loss. So the snowpack is controlled by gradients in temperature, humidity, and wind. So a warmer, drier, windier condition will lead to stronger gradients. And a stronger gradient just means there's a greater difference between the snowpack and the overlying air above it. And this drives greater sublimation and evaporation, and that's just snow water loss from the snowpack to the atmosphere rather than melt and into our streams. And vegetation plays a big role in this. So vegetation either strengthens or dampens these gradients. And so vegetation shades the snowpack from solar radiation, and it shelters it from wind. So warmer temperatures lead to two things. Warmer temperatures lead to earlier melt, which is further from peak summer runoff, earlier than we need it, earlier than when plants need it. And warmer temperatures increase this loss from the snowpack to the atmosphere. And so over 2 years and 10,000 snow measurements, I quantified the spatial variability of the snowpack loss. And on average, we lose about 15% of our snowpack to the atmosphere. And this varies spatially. So higher losses in open areas that's more exposed to sun and wind, greater gradients, and this is more important vegetation is more important on these south-facing slopes and in warmer years, whereas in shaded and sheltered areas with colder temperatures, reducing gradients, you see higher snowpack that lasts for longer on the landscape for plant water use and dampening late summer fire risk. So I'm working with forest and water managers to manage our forests, thin our forests in a way that maximizes these shaded and sheltered environments, because current thinning practices solely focus on wildfire risk, but we can do both things.
Judge, question?
So I'm just curious about the policy implications of this. Are ski resorts already looking at this as a better solution to use vegetation to help keep snow? Or I'm just kind of curious about those policy implications.
More in terms of like how you enact them, or
Sure, how you enact.
so
Is there curiosity about using vegetation to mitigate snow?
ski resorts are super interested. I mean, thinning our forests in a way on south-facing slopes matter more. So a lot of people think that if you get rid of all the trees, then you get more water because you lose the transpiration. So they're not using that water, we get rid of it. But that's not true. You expose it more to sun and wind. And so you can strategically manage the forest both on north and south-facing slopes differently. So on north-facing slope, yeah, you could get rid of more trees strategically, thin them, and ski resorts do that. And then on south-facing slopes, we want to retain the vegetation and build them strategically in these east-west orientations. That kind of answers the question.
Thank you, Baylee. Okay, moving on to presentation 3, Chance Moran.
The Great Salt Lake needs our help. Water levels are dropping, toxic dust is being exposed, and a critical ecosystem that supports millions of migratory birds, contributes $2.5 billion to the Utah economy, and sustains over 80% of the state's wetlands is at risk. So, with this changing system, we have to be able to answer a simple question: what is happening and what is going to happen? In order to answer that, I focused on lake primary productivity, which is the measure of the rate at which things like algae and bacteria convert sunlight into natural materials. Primary productivity is the basis of the entire food web, and therefore is a key indicator of lake health. Traditionally, models for lake primary productivity rely on biological field data. And to gather that, you actually have to go to the lake, meaning the data sets are small and sparse. So me and my advisor wanted to take a different approach, using remotely sensed lake color in modeling and forecasting. And specifically, we looked at dominant wavelength, which is a measure of lake color gathered from satellites over the Earth. Here you can see how dominant wavelength is gathered, as well as Great Salt Lake dominant wavelength over time. So my first research goal was to combine dominant wavelength data with field data to create a data set. And then my second goal was to use that data set to create a near-term forecast for Great Salt Lake primary productivity to better understand lake health. To do this, I created 3 models, one only with dominant wavelength data, one only with field data, and then a hybrid of them both. I used a Bayesian framework because it allows for us to handle missing data well and allows for the explicit partitioning of different sources of uncertainty. So what did I find? Statistical analysis showed that the dominant wavelength-based model had the best fit, while the hybrid model actually had the lowest predictive error. And this is exciting because it indicates that dominant wavelength may be able to capture some ecological signals. And then, to further analyze this, I created a forecast 5 months in the future for Great Salt Lake primary productivity, and I decomposed the different sources of uncertainty, finding that the major source was the process error, indicating that the models failed to fully capture a lot of the underlying complex ecological dynamics. So the key takeaway is that dominant wavelength and remotely sensed lake color are an important tool for understanding Great Salt Lake health, and combining it with traditional field data, it does improve predictions. However, accurately forecasting these ecological systems remains challenging, and going forward, more data, especially more frequent and better aligned measurements, will significantly improve these models. And so overall, we can see that this is a first step towards creating forecasting tools for the Great Salt Lake, tools that are increasingly necessary as the lake continues to change. Thank you.
Question?
How does lake color relate to lake health? What is the lake color capturing?
Yeah, so we think that lake color can capture some different dynamics like chlorophyll A and phytoplankton abundance. And by capturing that, because it's so base level and so integral to the lake, as like brine shrimp primarily feed on phytoplankton, and we think phytoplankton is directly related to chlorophyll, which is a proxy for primary productivity. So if we can therefore measure that and predict that and forecast that into the future, we can get a good look at what is happening in the lake in terms of like how this phytoplankton is interacting with chlorophyll A, and also that gives us like this really important information for just in general at this very base level, how healthy is the lake.
Thank you, Chance. All right, presentation number 4, Emily Dalley.
Hello, I'm Emily. I'm in the district lab in the chemistry department, and today I'm talking about tuned phase transitions and 2 dimensional perovskites for thermal energy storage. I know there's a lot of big scary words in there. Don't worry, we're going to go through it. So phase transitions are part of your everyday life. When you go outside and you sweat, it is the evaporation process of the water leaking the air from, not the air, the energy from your skin, which is what cools you down. And we also always use phase transitions in the AC, in refrigerators, where it goes through a cycle where it forces liquid into a compression and forces it into gas, and utilizes the gas liquid transitions to cool your system, just as sweat evaporation from your skin cools your skin. Phase transition materials can also be used in insulation purposes, where they absorb heat during the hotter parts of the day and can release it at night. Perovskites are a type of solid-solid phase transition material. If you have a rubber band and you stretch it, I keep clicking that. If you have a rubber band and stretch it really quick and hold it to your lip, it will heat up. That's the same sort of phase transition in these solid-solid materials called perovskites. Perovskites are made up of two inorganic layers that are separated by an organic chain. This organic chain melts at a lower temperature than the inorganic layer, allowing it to undergo a solid phase transition. The little GIF on the right is an example of one of my perovskites undergoing a phase transition. You can see when the light shifts up and down, that is the lattice spacing increasing and decreasing between the inorganic layers as it absorbs and releases heat. My main goal with these perovskites is understanding what changes this phase transition temperature. I have changed the inorganic layers and the organic layers and found that I can control this phase transition with the hottest being around 180 degrees Celsius and the lowest being 20 degrees Celsius. This is really important depending on what you want to use these materials for. 180 degrees Celsius is a lot harder to work with than 20 degrees Celsius, but it's all relative to what you are trying to utilize these for, if you're trying to do a refrigeration or some sort of other phase transition that you need. Thank you.
Question?
So what would be some real world applications of this?
So like you can use them in refrigerators where this is the same. If you see this figure, it's very similar to an actual refrigerator. So as you condense or increase pressure and release it with a heat sink on the back of your refrigerators, it's probably really warm. That is the heat sink. So the same sort of system can be used instead of liquid gas, which both run the risk of releasing into the atmosphere. But solid, if a system breaks, it will just remain where it is. So it would be a more environmentally friendly refrigerant alternative.
Great.
All right, the fifth presenter, Evan Klansnic.
So, hi there, I'm Evan, and I'm in the sociology department here at university. And what I really wanted to explore is how cities give guidance when we're experiencing extreme heat and poor air quality issues in a lot of arid cities in the West. There's a lot of interesting stuff that goes into it. But why is this important? Well, a couple things. Again, heat and air quality are becoming extreme issues in the Western states, and a lot of times we're seeing days where it's very hot and very polluted at the same time. So the question kind of becomes, if cities are providing guidance for heat and then providing guidance for air quality, is this guidance actually helpful for both hazards, or is it only helping each hazard individually? So what I ended up doing is that I picked the largest populated cities in the Western states, and then I also collected a ton of different materials, ranging from web pages, action plans, infographics, all to paint the picture of one, how they communicate guidance, and then two, what they're communicating them of. And I did this by creating very specific definitions of what behaviors were recommended. So for example, stay indoors had a very specific definition, and this allowed me to code the documents in a very consistent way when language between cities is so vastly different. So the main initial findings we found were that for heat, the top 5 most common behaviors were to drink water, use cooling centers, utilize shaded spaces, use water features, and then to limit outdoor activity. And then for air quality, it was to limit outdoor activity, monitor air quality, stay indoors, close windows, and then use AC and HVAC systems. Now this is pretty great guidance on its own. It tells you some varied ways that you can mitigate exposure, but the issue comes when you are combining both hazards at the same time. For example, when you stay indoors, when you were supposed to stay indoors for both hazards to help mitigate exposure, people who don't have housing can be not able to follow this behavior. Another great example is to close windows, or open windows for that matter. If you open a window to let cool air in, then you're also letting in polluted air. And even when it's extremely hot above your body temperature, the air can actually heat you up because it is hotter than your actual temperature. And a couple other cool ones is like utilizing shaded spaces. Usually that involves standing under trees or in infrastructure, but it doesn't really reduce your outdoor exposure to pollutants because you are outside. So in short, while cities recommend really good interventions, they don't for both hazards.
Question?
So I know you looked through a lot of different cities, and you looked at Salt Lake City, so how would you suggest Salt Lake City improve their messaging around these issues?
Yeah, so Salt Lake City actually does a pretty good job for air quality. For example, they have an air quality action plan for employees that basically when the air quality gets worse and worse and worse, employees are given better and better guidance to help mitigate it, even resulting in remote work. For heat, however, there's not a lot of information, and I only actually found one document that covered extreme heat guidance in any capacity to like what you should do. So what I recommend are 3 main things. One, we should have a more dedicated page on the Salt Lake City website that tells you what you can do during extreme heat, rather than having to find like an obscure blog post from 2023. Another great one would be to designate more areas and utilize more infrastructure, or I guess make infrastructure more aware to people. For example, the library is pretty good as a cooling center and as a way to reduce exposure to air, but I didn't find a document that explicitly referenced it as a place you can go. So even something as simple as having some sort of graphic that shows you all the places you can go would be pretty great. And then I think the third one is also coming up with ways to either fill in gaps of coverage for guidance, or to come up with guidance that helps both hazards. Like instead of recommending everybody to use AC when a large majority of renters especially do not have AC, maybe investing in more programs that allow them to have access to AC would make it easier and a lot more beneficial to people to follow that behavior. It's really all about access.
Thank you. Okay, number 6, Harrison LeTourneau.
Hello everybody, my name is Harrison LeTourneau, and alongside the LAIR group, I spent my semester addressing the problem of methane source characterization in complex urban environments. Methane is a very potent greenhouse gas, with a warming potential more than 80 times greater than CO2 over a 20-year period. And its sources are everywhere. Looking at gridded methane emissions in the US, we see sources range across cattle operations in the plains, to oil and gas infrastructure like in the Permian Basin, to pipelines and landfills in every major city. But the real challenge is complexity. Take the Salt Lake Valley. We have county zones like industrial areas, residential areas, urban areas, golf courses, and wetlands, as well as known point sources like wastewater treatment plants, oil refineries, landfills, power plants, and CNG filling stations, all combined into a single valley airshed. This source complexity is what makes characterizing emissions in the Salt Lake Valley and other urban areas difficult. One way of addressing this is through in situ mobile measurement. driving instrumented platforms through the valley to directly sample the atmosphere and plumes from both known and unknown sources. So this semester, alongside the University of Wyoming, we conducted 9 drives totaling 188 hours of data. 188 hours of data covering over 850 miles of the Salt Lake Valley. But what does this look like in practice? Here, we can see the van, pictured on the left, transecting a plume downwind of the Bountiful landfill. You can see the methane in red spike in the time series as we pass by the landfill. But this becomes really powerful when we bring in a second hydrocarbon, ethane. The ethane to methane ratio pictured in the bottom right acts as a chemical fingerprint for the source. A low ratio or slope is characteristic of biogenic methane, like from the landfill. And as we continue south and transect emissions from a nearby refinery, that ratio climbs, characteristic of thermogenic methane. To make sense of this data in near real time, I built a mobile Atmos dashboard. Here you can see as I select one of the van's methane analyzers and zoom in on the same area from the animation. First, I select a plume from a nearby wastewater treatment plant. You can see the biogenic ratio in the bottom left and southerly wind in the bottom right. Then I select the same landfill plume from before. You see its large methane enhancement in pink. And then I zoom in further as the van heads south towards Salt Lake. First, I select the refinery plumes from before with their high characteristic ratio. And finally, I select an unattributed plume in the middle of downtown Salt Lake. Exactly the kind of signature that makes this work so interesting. In essence, this work verifies that utilizing mobile field campaigns is a viable strategy for untangling heterogeneous urban airsheds, and my work directly contributes to the efficacy of these campaigns in the future. All these resources are hosted publicly, as well as the source code. Thank you.
That was a great talk. Have you been able to incorporate the USOS data from 2024 into your dashboard yet?
Yes, that's a great question. If you scan that link, I'm not sure if it's active right now, but there's 3 campaigns on there right now. One is from the ARC van, which drove during USOS, and then 2 are from this deployment, which there was one from last summer and then one from this winter, both of the Wyoming van. So the idea is with this dashboard in the future, we allow people to contribute their data from various mobile campaigns because it's set up to help not only increase the efficacy of the campaigns during the very often messy field work, but also help researchers get straight to analysis after the data has been recorded and processed onto the dashboard. Thank you.
Excellent, thank you. Okay, number 7 is Izzy Akers.
Hi everyone, my name is Izzy, and today I'm going to tell you a story about plants and pastoralists. So, throughout the world, we see lots of these rural pastoral communities relying heavily on their local ecosystems to survive. Unlike you and me who can just go to the grocery store when we're hungry. And these communities are being hit extra hard by climate change and variability, and they're also often the communities that are largely forgotten about when we talk about climate solutions. Additionally, the 2026 has been declared the International Year of Rangelands and Pastoralists by the FAO, and this indicates further need for information and just gathering data about these people. Today, in order to study climate variability, I'm going to be talking about a group of rural pastoral ranchers in Baja California Sur, Mexico. These people are primarily subsistence ranchers, meaning they really only farm and ranch for themselves. They're not selling to big corporations or anything. So what we wanted to know was, first, what plants are these ranchers using, and considering most important in their lives, and what factors drive the differences in plant use throughout the region. And to do this, we took 98 interviews throughout both regions, and we asked ranchers what were important to you,
what plants are important to your livestock, and what could you not ranch without. And ranchers were asked to give their top 3 answers to each. From this, we found, first of all, that geography shapes values. So the northern Uinta region versus the southern Cape region sees different answers in what ranchers think are the most important plants. Second of all, we find that the top plants are, we were able to just gather a list of those because that was not previously available. Of all of those, the 3 you see here are federally protected by the IUCN, and so they're not only culturally important to the ranchers, but they're also ecologically important as well. These are also the same plants that are being hit hardest by the drought and overconsumed by these ranchers. So this begs the question, how do we balance environmental protection with the livelihoods of these people who depend on plants every day? And our hope is to just work with local governments and provide this information as a way to kind of find economic alternatives as well as solutions to these problems worldwide for other rural communities. Thank you.
Questions?
What's an example?
Go ahead.
What's an example of why one particular rancher in one region might value a plant like you mentioned more than ranchers in other regions?
So the two regions have a different microclimate. So we see in the Southern Cape region, this bottom right here, it's a little bit more humid, tropical. It receives more of the oceanic air, and then this Hidalgo region is more arid and higher elevation, and so the plants that are growing in the areas are just slightly different, and that's the main reason we think. Yeah.
Thank you, Izzy. All right, the 8th presentation, Julie Moyano.
Hi, I'm Julie, and I'm a former Wilkes scholar, so they told me I could present on anything climate related, so I'm presenting on skin cancer. So climate change can impact human health in a variety of ways. One negative impact potentially being an increased risk for skin cancer. This is because one of the primary causes of skin cancer is ultraviolet radiation or UVR exposure from the sun. The ozone layer protects us from skin damage by filtering out much of the sun's harmful UV rays. However, with ozone depletion, more UV radiation is able to reach the Earth's surface, making UVR exposure much more intense. Additionally, with rising global temperatures, we're experiencing hotter days and longer summers. And research suggests that we're more likely to spend time outdoors, which could lead to more opportunities for UVR exposure. Skin cancer is a disease that can be dependent on environmental factors, which is why it's so important to understand how skin cancer and climate change may interact. So the impacts of climate change on skin cancer are especially pertinent to Utah. Melanoma is the deadliest form of skin cancer, and Utah has the highest rate of melanoma in the entire United States. While climate change is defined by long-term trends, some of its effects are already noticeable for us here. The average temperature has increased by 2.5 degrees Fahrenheit in the past century, and our winters are becoming warmer and shorter. The combined effects of ozone depletion and increased time spent outdoors may put us at higher risk for UVR exposure. And skin cancer and climate change are both huge concerns for us here in Utah, making it important to consider the potential connection between the two of public health risk. So I'm talking about skin cancer today because I work at the Huntsman Cancer Institute as a study coordinator for the LeTourneau Research Lab. We do research on behavioral interventions for melanoma prevention. If you're interested in our work, I have the link there. So here I have some data of a study that we did with University of Utah undergrads. We found that students are spending an average of 2 to 3 hours outside, which is a considerable amount, but not many reported wearing sunscreen. And then this is a graph of the number of sunburns in the past year. And as you can see, 4 more is a category with the highest frequency. And then to end things on a positive note, I'll leave you some easy tips to protect yourself from UVR exposure. So wearing protective clothing, sunscreen with at least SPF 30, and then trying to stay in the shade and trying to avoid peak UV hours. Thank you.
For the survey, did you guys ask why most people weren't wearing sunscreen?
So it's like a clinical trial, and so the survey is like long, like 30 minutes. So we ask them all sorts of things. Like we ask them, like what has prevented you? We do like an intervention where we do like an action plan. It's like we have them like set goals to be more sun safe. And so usually what like students usually say is like, oh, like I forgot to wear it. I don't like the way it feels. Like, oh, I don't have any in my house, so I'm just not gonna put it on. Or it's too hot, so I can't wear long sleeves. That's kind of one of the main ones. Or I can't avoid peak UV hours, like I have work at 12 p.m. or I play this sport at like a certain time. So those are kind of the things that prevent young people from doing protective behaviors.
Thank you. Okay, presentation number 9, Nawshin Tabassum.
Thank you. I'm Nawshin, and today I'm going to present my research on climate adaptation for active transportation. What can we learn from the plans of 100 largest US cities? So we all know that active transportation such as walking and biking is considered as the most sustainable mode of transportation because there is less carbon emission. And people who are actually walking and biking, they are more vulnerable to these extreme weather events rather than the people who are driving. And the cities are asking their residents to walk and bike more as a climate mitigation measure. But what are the cities doing to provide them with safe and comfortable walking and biking facilities? So that's what I'm going to explore nationally, and I'm choosing 100 largest US cities in the US and see how they catalog the climate adaptation for active transportation strategies in their planning documents and how these strategies vary based on the city's context. And my research is very much dependent on the adaptive urbanism theory, where we try to provide resilient street considering climate adaptation, mitigation, and placemaking altogether. I'm not going to talk about the methodology. It is very much of a traditional content analysis where I selected 279 plans like a climate action plan, active transportation plan, bike and pedestrian plan, and try to understand how they include these strategies. And what we found that most of the cities are talking about heat and stormwater related issues. And whenever they talk about heat, they talk about tree planting and also green space. And there is this green infrastructure, which is considered as one of the most efficient ones to deal with both heat and stormwater related issue. But if you want to provide tree, there are some strategies that you find very hard to implement because there are sometimes conflict with utility lines, it causing damage to the sidewalks. And there are sometimes pushbacks from people because they think it is very hard to maintain the trees. And as we looked at the other concerns of the cities or city structure or characteristics, we found that the cities who have higher number of people who belong to the minority population or in the low poverty level, the cities actually include these strategies more rather than the cities with less number of these people. So what are the policy implications? You need to have ordinance in place, such as Laredo has their green space ordinance to protect their trees. You need to prioritize your minority population. There needs to be proper collaboration between the city departments and also with the local people, and there needs to be funding. Thank you.
Question? Judge.
I was wondering, why do you think there's that relationship portions of people in poverty and minoritized populations, and then more planning strategy.
Thank you so much for your question. When we talk about walking and biking, most of the cases, the low-income communities, they use walking and biking more, and they also try to use these modes to access transit, and they have less access to, any kind of car or any secondary mode of transportation. So I think when there are pushbacks from the communities and there are more use of this, then they try to provide not only better active transportation and also provide shade near the bus stoppage and other places. So it's dependent on the kind of the user group of the cities. Thank you.
Thank you. Okay, the final presentation now, Sydney Smith.
Alright, real quick before I get started, I want to let you all know that there is yet another QR code opportunity at the end of this presentation, so please keep your mobile devices at the ready. But to kick things off, I'll conduct a quick poll. So by raise of hands, how many of you have a lawn that you water? Okay. How many of you took a shower this morning? Alright. And how many of you has had a drink of water yet today? Okay, that's good to see. Perfect. If you raise your hand in response to any of these questions, you are a water user in the Great Salt Lake Basin. My name is Sydney Smith, and for the past year, I've been doing work in the Department of Atmospheric Sciences studying summer precipitation across the Great Salt Lake Basin. And in partnership with the U.S. Bureau of Reclamation and the Utah Department of Natural Resources, we've been working on the Great Salt Lake Basin Integrated Plan. This plan is working to inform water management decisions in the face of climate change across the Great Salt Lake Basin, which is shown here in red. And this will in turn impact how water users like you are able to interact with the resource itself. Now, our first step as a part of this project was to develop a high-resolution data set using the MACA V2 method. This is much better at representing atmospheric variables and complex terrain than a coarse-resolution global climate model. Next, evaluating changes in temperature by the end of the century against changes in precipitation, there was an interesting relationship that emerged that shows that there's a divergence in precipitation ratios, especially in high greenhouse gas emission scenarios, that is SSP 585. But why? Selecting a wet, moderate, and dry case scenario for each of these, we mapped synoptic scale or large scale variables to better understand what was driving these differences. What appeared is there's a regionally distinct pattern in precipitation anomalies, and this is driven by increased convective activity from rising temperatures and also from transport of monsoonal moisture. This offsets the local drying tendencies by increasing local moisture. But we're also curious in trying to understand what this might mean for what of these possible features is most likely to occur. So doing some look at comparing historical global climate model data to observational data, we found that models that are characterized by a dry bias and models that have less variation in precipitation from year to year have the biggest range in precipitation outcomes. Now note that models that perform closest to observational data for these same metrics, that is to say x equals 1, still have a considerable range in what their projected precipitation outcomes are. Now, this analysis reveals that removing models from the dataset based on their historical performance cannot be used to substantially shrink the range of projected precipitation outcomes. As such, water management plans like the Great Salt Lake Basin Integrated Plan should consider a wide variety of future hydroclimates in their water management decisions that will ensure resiliency in the face of climate change. Now here's those QR codes that I promised, one for a website that I developed with more information on the research and one that contains the code. Thank you very much.
Question from the judge?
I just wanted to know, how did you define precipitation?
Go ahead and ask into the microphone. Thank you, yeah.
How did you define precipitation in Utah? Because I'm doing similar research, so I just wanted to know.
Precipitation in Utah is defined basically by the global climate models themselves. They have variables that they define, and this is based off the CMIP6 data set. So the variable itself is predefined by a data set that we use that was publicly accessed and then downscaled into our high resolution data set.
All right, thank you. Okay, all right, so at this point, in order to facilitate the voting process right now, because it's going to be hard for everyone to remember everyone's name and their talk, what I'm going to have you do, as the slide indicates, as I announce your name, let me see here. Okay. I'm going to have each of you come up and order that, and then just, along with your name, just give the title of your project again. So we'll start with Aspen. Do you want to come up and just remind everyone, basically?
Yes, my name is Aspen, and I live at the station on Thornton, our called Disparities in Salt Lake City, Utah.
All right, Baylee.
Strategic forest management to minimize wildfire risk and maximize snow water.
Chance. I think we can vote for two. Isn't that the process there? Yeah. So.
Yeah, mine was, can we predict the future of the Great Salt Lake?
Emily?
Tuning phase transitions into two-dimensional perovskites.
Evan, and then what do cities tell people to do during extreme heat and poor air quality?
My name's Harrison, and mine was methane source characterization in complex urban environments.
My name is Izzy, and mine was plants and pastoralists in California sewer.
I'm Julie, and mine was impacts of climate change on skin cancer.
Hi, I'm Nawshin, and mine was climate adaptation for active transportation.
Hi, my name is Sydney, and I was presenting on uncertainties in future precipitation values across the Great Salt Lake Basin.
All right, thank you all. And so we have two votes. This is everyone this is open to. You can vote if you're by scanning the QR code I'm going to put up on the next slide, but you can vote for up to two presenters. Okay, and so yeah, please go ahead and take your vote. Anyone can vote.
You can vote for yourself.
You can. We're actually a little bit ahead of the schedule. I just wanted to say, so everyone understands how voting works and is voting right now. The announcement for the winner will be made at 4:45 in Dumkey. And winners, I just want to remind people, if you're selected as a winner, you have to actually complete the W-9 form by hand in order to get paid. Like, that's just an important detail to remember. Is there anything else, Kara, that I'm forgetting, or is that?
No, you don't have to be present. I'll say that. You don't have to be present to actually win any of the awards, poster or lightning talk, but it's wonderful if you can be here so you can get a nice photo taken. And also can we get a round of applause to the judges who are doing the like professional judging.
Yeah, and great work to the students too. I'd like to give them a round of applause too. All right, that's it.